Hi, everyone. I want to talk a little bit about slides 5 and 6, I believe. So these are slides 5 and 6. Let's read through in case you have questions. Finding theta, the angle of elevation. And if you look down at the bottom of this page in the bottom right-hand corner, here's theta. That's my angle of elevation next to this little crew member dude that I picked. That's the Elvis dude. I like to picture him. And one of the crew members, so that's the crew member standing at the angle of elevation, is 500 feet away from the bottom of your landmark. So I would like you to delete this whole sentence, and that's where it says write the distance from theta to the bottom of your landmark, and that distance is going to be 500 feet. Then we have at the top in our instructions, use the height of the building. So it's either going to be a building, whatever your landmark is, and the distance of the crew member to find the measure of the angle of elevation theta. And remember, we pronounce it theta, and it looks like this kind of oval with a kind of curly in it. So one of the things that you needed to do in the previous slide was to figure out the height of your landmark. And something interesting I was working with another student on was that they found the height of their landmark, but it was in meters. Meters, it's completely spelled that wrong. I'm sorry, you guys, meters. So they needed, since this was in feet, they needed to change that to feet. Or you could change 500 feet to meters. Either way, both of these numbers need to be in the same units. So that's just up to you. That was just an explanation, or you could just try to figure it out online. Make sure that you have it in feet when you find that height. So let's pretend that I found the height of something to be 300 feet. Okay, and so both are in feet. And here you want to paste a picture of your landmark. Let's say that I did, I don't know, Big Ben or something. I'm making all of these numbers up. I would put Big Ben right here so that I think it's just like a clock so that it lines up with how tall my triangle is, because I'm going to use this right triangle to figure out this angle of elevation here. And the angle of elevation is that angle that leads up from that distance. And the way I'm going to do this is you have to decide which trigonometric function you are going to use. And since I have the height of this triangle, and since I have the distance at the bottom of this triangle, the base, and my angle is here, remember the sides that we learned, the opposite, the adjacent, and the hypotenuse? I know that this is the hypotenuse. And this, how tall your landmark is, that's the opposite side because it is not touching the angle. And then this side right here, that's 500 feet, that's the adjacent side because that one is touching the angle. So we have numbers for the opposite and we have numbers for the adjacent. So if you remember how we learned, a way to remember these is that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the, oops, I forgot my H, over the hypotenuse. Good Lord. Let me rewrite that. The cosine is the adjacent over the hypotenuse, so ca, and then tangent is the opposite over the adjacent, toa, so katoa. And since I'm using the opposite and the adjacent in this triangle, we're going to use the tangent function to solve this, or the tangent ratio to solve for our angle. And what that looks like in this particular case that I just made up is that the tangent, ooh, I like this color, of theta, you can put that in parentheses if you like, is equal to the opposite side, which is 300, over the adjacent side, which is 500. basically 3/5, but I'll just leave it like that since I'm sure most of your work won't be as easy and nice as that. So if I need to find the angle, I need to get the angle by itself, which means I need to do the inverse tangent of both sides. So I need to take the inverse tangent of both sides. And it's not multiplication. So actually, I want to write it below so I can write it in front. I want to take the inverse tangent of 300 over 500. So taking the inverse tangent on both sides, that cancels out the tangent on this side. So I just have theta. And then the number I get when I take the inverse tangent of 300 over 500 or 3/5 is going to be my angle measure. So let me pull up my calculator. Okay, so I have my calculator. You have one of your calculators that you're using. And we are going to do, since we're doing the inverse tangent, we have to hit the second button first. If you're using that NumWorks calculator online, it's the shift button, but it's mostly in the same spot. And then you hit the tangent button, which is above the 9. So that's the inverse tangent. See how it came up with that -1 as the exponent. And then we're just going to simply put 300 divided by, that means over, right? 500, parenthesis. For those of you using, actually for all of the calculators that you are using and the Chromebook One TI that you guys have, it always goes back, the mode always goes back to radians. So before you hit enter, you're going to need to go into mode. Look, mine did too. That's weird. Go into mode and arrow down. On mine, it's 2. Arrow down twice. Yours might be 3. And then right arrow over to degree and hit enter. And then if you hit clear, it should take you back. So you have to make sure you're in degrees or you're going to get a funky answer. And remember, that's just because there's different ways to measure angles, just like there's different ways to measure like heat. You could do Fahrenheit, Celsius, or distance. You know, there's tons of different ways to do distance, from meters to feet, inches, millimeters. But we're working with degrees. Next year, we'll work with radians. So I have the inverse tangent of 300 over 500, hit enter. So, and I think let's for this project go at least just 1 decimal. Ooh, well, in this case, let's do 2, because if I did 1 decimal, it would just give me a whole number. So I'm going to go 2 decimals. So theta is approximately 30.96 degrees. Okay, so theta is approximately 30.96 degrees. And down here, you can just type that in on this slide. It says the measure of angle theta, and we will put 30.96 degrees. And I believe that's all you need for this slide. And you don't need to put all of your work on this slide, because our next slide is where you're going to put all of that work. So for this first question, which trigonometric, oh, I spelled that wrong. You guys are going to have to fix that in your own. Miss Binkley. Actually, I should learn how to spell. I should go back and learn how to spell. It makes me look really terrible. Trigonometric ratio. Which trigonometric ratio did you use to be able to find the angle of theta? Take a moment. Which one did we use? Remember, we have sine, we have cosine, and we have tangent. Which one did we use? We used tangent. Why? We used tangent because we had numbers for the opposite side and the adjacent side. And I'm just putting in some bullet points here. I expect you to write me some nice sentences for this, okay? Number 2, write the equation that you are solving to find the angle measure. And that's the equation that, I'll put the equation that I just used. I said the tangent of theta was equal to 300 over 500. Show your work for solving the equation. And this is where it's probably just easiest to insert a picture. When on these slides, you go to insert, image, and then find camera. Just hold your work up to the camera to put a nice little picture right in here. Feel free to type it up. It would be cool if you could do a screenshot of the calculator. That would be pretty dope. Any ways you can make it as cool and neat as possible, please do that. And question 4, what does your answer represent from about this situation? What does your answer represent about this situation? Well, what did we find? We found that our angle of elevation from the ground to the top of the landmark. I'm writing a lot. Landmark. There's one more piece of information I want to get in there. From a distance, because it could be, the angle will be different if I'm standing a different distance away. From a distance of 500 feet is, I still have to put what I got, is 39.96 degrees. Okay, so all of that for this one.